Hi everyone. In today's video, we will deep dive into non-standalone access signaling flow. I will go through the call flow for the accessibility. Particularly, it's about the SgNB Addition signaling, and we'll also covering all the related aspects about this part. And we will also explore all the potential failures for the SgNB Addition and their causes and effective troubleshooting methods. And the most important part that I would like you to know that this will be like a non-standalone series where I'm going to cover many different things. The first one is the accessibility, then we'll go through the drop throughput and main features and even some insights of how to increase the traffic and so on. So will be like a detailed series about the non-standalone, which hopefully will be covering most of the related theoretical and practical examples of the non-standalone. So let's move directly to the contents and see what we're going to cover today. So as you can see that the first part is going to be done for today. I'll just give a quick recap about the non-standalone network overview, particularly about option 3x. Then we'll go through the signaling, 3GPP signaling for the secondary cell. I'll be explaining what is the signaling flow starting from the 4G till we have the 5G SL being added. Then we'll explore all the components, the key elements information for the most important message within this part, which will be very important for you to understand, because this will help you during the troubleshooting for any particular case or any issues in the non-standalone. And lastly, you will be ending about the top cases or guidelines or NSA troubleshooting guidelines related to the accessibility issues, and I'll be listing most of the common issues which you might face it in any new network or even in the current network. So now let's move to the first part, which is related to the overview. So as you can see here in this overview part, the part on the left, this is NSA network option 3x. If you can recall that in all cases that non-standalone means that the 5G is still relying in the ABC or the 4G core and the 4G node as a backbone, right? They are like the backbone for the 5G. So in this case, you can see, for example, the signaling here is still being controlled through the 4G part, and we have the data or user plane because this is option 3x. It will be flowing from the core network with serving gateway and MME towards the GNB. Then the data split will be happening from the GNB. It will be sent some data through to the NB, and the others will be transferred directly to the non-standalone users. So in all cases, for sure, the first part should be go always from the LTE until it add the secondary node. Then we can transfer the path from the NB to the GNB. We'll explain this in more details in the next slide. And here this is just overview about the overall signaling which we are expecting to cover in our series. For example, if you look into this figure, this is showing that, for example, this is 4G and 5G co-located site where we have the master A node B group and secondary G node B group, or secondary G node B, and here this is the neighbor side. So initial here there is no, this is red color is the 5G coverage. Here there was no coverage for the 5G, so just making the initial access, the user keep enjoying 4G service until he moved to the 5G red circle, and here where the SgNB addition is being triggered, and this is where we are going to discuss about the signaling flow and all the troubleshooting things. Then after that, it can be there is mobility, SgNB change, and even master NB handover, and after the user move outside the coverage, the GNB will and the NB will be releasing the connection. So will be covered in later sections. But the first important part I would like you to always keep it in your mind is the concept in the bottom right here. We have something called, which is the ENB, and something called, especially in option 3x, second regional B, which is called GNB. Now you will always hear this kind of concept or expressions, MCG, master cell group, or secondary cell group. For example, what it means by master cell group. If you look into the cell 1 and cell 2 and cell 3 and cell 4, master cell group means that anything falling under the unit B cells will be under the master cell group. For example, in this particular example, I'm showing that there is two cells, which is cell 1 and 3. So this is the master cell group. This is the cell group of the master unit B. And the same for the secondary cell group. You will have cell 2 and 4, but this will be for the SgNB or for the GNB, which is called secondary GNB. And about the cell itself, you will find always this kind of expressions called B cell, SP cell, or B as secondary cell. And that's what it means by that. Means primary cell. Primary cell, this is the primary cell, which is particularly cell 1. This is the primary cell for the GNB. Then you will have this secondary primary cell. Sometimes you call it primary secondary cell. But just keep this in mind, because in the signaling RSA configuration, for example, any RSA configuration related to the 4G, you will find this called SP cell, SP cell. So this means this configuration being delivered RSA configuration is related to the GNB. So the SP cell, which is the secondary primary cell, is cell 2. Then you will have the secondary cell. Secondary cell is any secondary cell for both nodes, which is cell 3 and cell 4. Keep this in your mind, because this is very, very important, especially when you look into RRC configuration message. You will always see SP cell, SC cell. So you'll understand that SP cell is mainly for the unit B primary cell. Then you have this kind of carrier component, which is, I think, clear from carrier aggregation, which whatever we have it before. For example, carrier components, that we have all the cells under the carrier component. Then the primary carrier component, which is cell 1. Then you have primary secondary carrier component, which is cell 2, then the secondary carrier component, which is cell 3 and 4. So, but the most important here is this cell group and the cell, which is, and even the base station. This kind of concept, so try to understand it very well, because this will make it easy for you to understand in general the non-standalone network. So let's move now to the next part, which is related to the signaling flow. Okay, so you can see here in the left figure, we have detailed signaling flow. Here, I usually you will see only the bottom part, starting from F5G SL addition till the path switch procedures, but you have to keep in mind to understand the complete flow. For example, if you look into this figure, this is the complete signaling flow. This is the first phase which we have it. The first phase, for example, assuming the user starts from idle mode. So the user was 4G in idle mode and 4G. So he need to complete the initial access, right? Where you have the RRC setup procedures. Then will be the GNB will be initiating after completing RRC the initial UU message asking to start establishing the context. Then the MME will forward this initial UU context setup request, which is very important to explain in details, to establish the context for this particular user. So it will send it for this user. Then there will be some procedures to check the UU capability, security. Then after confirming these two bars for UU capability and security, the InnoD will forward this kind of information, which is being sent under the initial UU context setup request. This one usually containing the ERAB ID and quality service information. It will be forwarded from the InnoD within this message RSU configuration to establish the context for this particular EE. Then it will be completed. After that, once it's been completed, now we can consider as bearer being established and the context being established for this particular user. And for sure, there was exchange of the capability here. After the confirmation from the UE, it was being sent to the MME, and this can be even stored for the next call. So maybe for the next call, you will not see this kind of UE capability information in case if the information is still available in the MME. So as you can see here, for example, once you have the initial access, initially before having the context being established, you will have this, you can see the signaling flows being established for option 3x from the core network to the 4G. Now you have the signaling flows being established. Once the context being established, now which is called usually data radio bearer or DRB. Once you have the DRB, now the user can start doing like data download or uproot. As you can see now, this solid line, the black line, this is like considering the data. So you can see now there is a data transfer. So now the 4G is being completed. Now, after that, the user, after checking the capability of this particular user, the network find that this particular user is capable of 5G non-standalone, and already we have 5G in this side. So this was the high level. First, this was the initial access being done. Now, the next step, once it's being confirmed that capability is being supported, the InnoD should deliver the related configuration if you assume that's based on measurement. For SgNB addition in general, it can be measured to blind. So based on the measurement, the InnoD should deliver all related configuration. We discussed this in details. For example, B1 events. What is the time to trigger? What is the RSRB threshold? So this information will be triggered here. Once, for example, the users check this B1 RSRP threshold, once it's being achieved, it will be starting reporting the measurement report to the InnoD or master node. This is called MN, which is InnoD master node. So once it's being received, the measurement report received by the InnoD, now it starts establishing the SgNB addition request. Actually, sometimes, and this is also vendor based. Before this step, there is another step. Assume there is no X2 connection between these two nodes. There is no X2 connection. So that might be before that part, if NR is being enabled and the X2 auto setup, if there is no X2 already established, so they might find X2 setup request and setup response to try to establish the X2 connection. This is in case if it's not available. So we are assuming now you have X2 already established connection, so that there should be now available communication between both of them. So now the SgNB addition request will be sent, and this will contain all the information within this measurement board and other information related to the transport layer information and many other information will be covering in more details. So this will be covering what kind of information this measurement report. The NLB now is asking the GNB to start adding this kind of, it's asking that I would like to add because the user is confirming that he's now meeting the threshold. So the GNB will evaluate this SgNB addition request. And here we already bought the second point, which is 4G delivered the RSA configuration that you reported the measurement report. Then now we are under this 4G trigger SgNB addition procedures. So now what will happen? The GNB will evaluate this SgNB addition request if all achieving the conditions. In this case, it will forward the SgNB addition request acknowledgement, which is giving all the information about the SgNB. Like, for example, what is the BCI, what is all the SSP location, and this kind of information. We'll also covering details. Then again, the unit B now will start adding or configuring the SgNB to this particular user through RSA configuration message, which will almost contains the exact information within this message with some extra information. Then the user will be confirming here. Once the user confirming and replying here, then the confirmation will be sent to GNB. Now here at this particular point P, we can consider that now we have the SgNB being added. If you look into that, now we have established a connection here at this line. So now, but still the path, still the data transfer is being handled through the 4G network. Still, we didn't change it to 5G network. But till this point P, now the SgNB addition being added, but still the data transfer is being through the 4G and the split it through the 4G. So if you look into this point A and point B, this is where the SgNB addition success rate can be measured. For example, here, this is the first one addition request, then the complete. So if you divided this is the complete divided by the attempt, then you will have the SgNB addition success rate. And to give you one important message here, that for example, anything happening before that, if for example assume that you might have a failures here, it will not be reflected in the success rate in this particular case, unless the vendor have other methods. But this is as per the theoretical understanding should it be covered here. So sometimes you might find a problem, especially if you are here in this failure at this particular area initially you access, you might find a problem, but it's not me covered in the KPIs. So for example, you have less traffic in users, so we need to investigate why we have low traffic. Maybe due to view capability, problem in the reconfiguration message. So this will be explored as well. But this is, you have to keep it in your mind that this is where the KPIs probably will be counted for the different vendors. And this, after that, the user will be starting doing the random access. And after doing the random access, you can see that the serving gateway is still forwarding, making the data forwarding towards the inode B. And this should not be case. Now we should extend the path because this is option 3x. So here, where the inode B, master node or inode B will send this path, it will start the path switch procedures to change the path. It will like to make the serving gateway to send the data direct to Juno B because this is option 3x. So it will send this era modification indication, which is simply is to change the path of the it's transferring the information of the of this particular SgNB to the MME, telling him I would like to modify the path, my path, instead from the serving gateway sending to me, I would like the serving gateway to send to the GNB. And this is what will happen here. Then the MME will send this notification to the serving gateway. Then the serving gateway after that will send something called end marker, which means informing the NLB I'm not going to forward any data to you anymore. So once this being done, now this ERAB modification confirm will happening here, and now we can see now that the path has been changed instead of from the EBC or the serving gateway and MME sending to 4G as data, now to be transferred to the 5G, and data split will be happening. And this is because of option 3x. So as you can see as a high level here, once we reach it into this SgNB addition procedures, and this SgNB addition request acknowledgement and RSA configuration, this will be containing all the information about the SSP. So the user will start searching for the SSP and complete the downlink synchronization. Once the downlink synchronization is being completed, after he will start the ratch, then it will be uplink synchronizer. So this is high level. Now let's go through the content of some of the messages which have it here. For example, initial context of request and all the information, most important information. So moving forward, now here we're going about the initial context of request. This is the first message was coming from the MME to the NLB to try to establish the context. Actually, this is very important because you can see I'm highlighting here on the right in this table the mandatory information and the optional information. For example, mandatory, this is ERAB MBR, maximum bit rate. This is will be forwarded later on through the SgNB request from the eNodeB to master eNodeB. And here, just to highlight, here, for example, we have the ERAB setup. You have this kind of information for ERAB, identity quality of service parameters. For example, it will establish a particular KCI, let's assume KCI A7 or whatever. And when this part, you might sometimes have a failures in case, for example, if this peer is being configured for emergency calls, so it might having high IR. So in this case, this peer cannot be for secondary cell. So for example, here only use a specific ARP value are considered for secondary cell addition. So also this is rare condition, but just keep it in your mind. And you will have some information about the transport layer address. For example, here just telling him about the serving gateway IP. This is the main idea. Here, the most important, number 3, this is optional, but sometimes the core will do some restriction on particular users, maybe due to the subscription or whatever. So you'll have something called NR restriction ABS secondary route. If you look into this message, it's saying that inclusion of this field within this initial contested request, this is like it's called an restriction EBS secondary route. This indicates that this user is not subscribed to 5G. There is no subscription for 5G. So in this case, the ENB will prevent the SSL addition for this particular user. Simply, it will not deliver the B1 event, which is this configuration, if this being sent here. After that, you will find sometimes the readability, or most of the time, including within the initial context help request, and this is being stored from the previous message. And for sure, this is being used to confirm the capability, because sometimes the user might not be supporting the capability of the 5G or the band combination. So in this case, this can be used also for the admission control. So the ENB also found that this particular user is not supporting, it will not deliver again the B1 related events. So this means also you will not have 5G in this particular case. Then you have something called SPID. This SPID, for example, this would be delivered. This is like if you are enabling this feature, which is called subscriber profile identity. If you have this, you can give a particular MZs or users, a particular ID will can be used to use, for example, a particular mobility setting. For example, some users might have a problem, or you want to make a special tuning for them, so you can give a very aggressive setting for those particular users. So this is also can impact or based on your settings in the network. And also there is information here I didn't highlight here called IME or IME SV, which is International Mobile Equipment Identity software version. This is also being sent in this message, and this also can be used to give a particular settings for the user. So this is actually the initial content setup request. If you look into the message content, as you can see in the right figure here, the message content, this is the same. For example, you find this ERAP to setup to add to mid list. This is from the logs, and you find that, for example, here giving the XI 9, and this is a priority level. You have the ARP information. You have the transport layer address, which is the serving gateway IP. And also you have other security and other information. So this is initial context of request. Now let's move to the next important message, which is related to the RRCB configuration and measurement report. Once here the capability is being confirmed and there is no problem in the capability here, the user is comporting GNB and there is no any other issue, which being, for example, there is no restriction. The GNB now will be forwarding the UE with RRCB configuration, which include the B1 related events. If you look into the right figure here, this is, for example, in this particular case, this is RSU configuration is telling him that the RSRB for the to add the SgNB or to measure the GNB should be 45, which is equivalent to 112 dBm. So if you are measuring now, start measuring the 5G. So if the 5G is better than 112, now you can send the measurement report. Otherwise, don't send it. And this is just another information about the time to trigger. For example, this should be done for 512 milliseconds until the user send this kind of measurement report. And this is just related information also for the report amount, history, and so on. And once the measurement was being sent, this will include the information about the BCI of the GNB, which is being reported, or the best cells. For example, in this case, the RSRP of the neighbors was equivalent to 77, which is also make it minus 157, will give minus 80 dBm. So now it's being reported. So the next step that the ENB will forward the SgNB addition request from the ENB. It will forward to SgNB, start adding the SgNB addition. So let's see what kind of contents we have it in this SgNB addition request. So moving forward here, as you can see, this table also the 3GPP table. This is showing what kind of mandatory information we have and what kind of optional information. Okay, if you look into this table, you'll find it having a lot of information. Most of this information was already covered, already included initial EU context setup request. So actually, for example, you find this like of aggregated maximum bit rate, which is being included here. Also related DRB, which is data radio bearer, quality of service, what is the KCI being used, and so on. All this information, which was also included in the initial context setup request. But the most important information, which maybe you needed in troubleshooting, this kind of called CG or configuration info must be to SgNB container. This is including all the target or the candidate of the 5G cells, which is being sent in measurement report. It will be included in this message. If you open this and from the traces, we have X2 traces. If you open SgNB addition request, you search for CG configuration info. You'll find under that, you'll find the related BCI and RSRB and this kind of information for the target cell, which is will be evaluated from the SgNB until it to be added. Also, you'll find the cell ID of the master NLB for this one as well, and also the same information masked IMS. This can be, for example, used. This is as I mentioned for you. This is the international mobile identity software version. This can be used, for example, if you have features and different vendors have different names. For example, this feature can be used to give a specific mobility settings, for example, for a particular device type. This is, for example, or you might have some problematic devices. So in this case, you can use this part to block those devices from taking 5G. So this is also one of the cases being used here. Other information also related to the, for example, handover restriction, which is being involved here. So if there is a restriction in the handover or adding the cell, so this means that you will not find the SgNB in this case will not accept this kind of SgNB addition request. Also here, there's something called SgNB addition trigger indication, but this is optional. You will probably will not find most of it except masked IME. Probably you'll find it. This is just giving you, for example, this SgNB addition, why it's needed. Sometimes it's needed, for example, if there is SSL change or there is intra ENB handover, intra ENB handover. So now let's move through the contents from the log file. As you can see here, for example, for the same message, which is SgNB addition request, you can see first that what is the ERAP to add it to mode list. You'll find that this is giving the quality of service, KCI 9, what's kind of priority level, and also again the serving gateway and other information regarding the master ENB, and also for the downlink, uplink. For example, this is the transport layer, and you will find here, for example, this is the transport layer also for the uplink. So this is just to configure or to inform this particular about the paths which we have in the network now. And here, as I told you, this is the most important. You have this CG configuration information. This will be including the information of the which being sent in the measurement report. For example, this is PCI 228. You have the RSRB 26 and the RSRQ 62. Then you will have this SBID. Sometimes you'll find it. SBID can use to have the specific settings. And now we have the B element identity and also the cell ID of this particular user and market IMEC. Sometimes you'll find this information here. So now let's check next message SgNB addition request. This is very important information because if you understand it very well, whenever you have a problem, it will be easy for you to investigate. So now moving to SgNB addition request acknowledgement, you can see in this particular message also there is a mandatory information. The most important part, this is just ID for the X2 AB to differentiate between the users. So this is just ID, which is being shared for the master NLB and SgNB to identify the user in the X2 interface. So for example, here, this is ERAP admitted. For example, the information will be following here that the SgNB is telling the ENB which kind of information I have for the I am admitting which ERAPs, which kind of ERAPs you shared it with me, I'm admitting it. And also it's sharing back, if you look into that part, that this 5G secondary node provides a list of ERAP which have been admitted and specify the following. The second point particularly, that the 5G secondary node, this one, will give again its own transport layer and GTP tunnel for transferring uplink data across X2 interface. This is just telling him about the kind of transport layer, serving gateway, and all the addresses, even the ENB, GNB IP, and so on in this particular message. And again, again, the most important information here, it will be regarding the master NLP to GNB CG version information. You remember here we used to have the same information that we're giving him multiple cells. Now the GNB decided which one will be selected, and now it will be sending this information under this message, which is called, for example, include my target BCI is this, but this is my SSP frequency, and this is the RATCH related parameters, and this is the bandwidth part related information and BUCH and more other information. Just it would like the UNIB to send the UNIB, and it would like the UNIB to forward this information later to the user to start accessing to this particular cell, and this can be delivered through the RSA configuration message. And the RSA configuration will be containing the exact same information. And the last one here, in case if there is a particular ERAB is not admitted, so from the 5G node, the 5G will send it in ERAB not admitted. Usually you will not find this part. And this is quickly here, you can see. If you remember in the beginning of this session, here, for example, in the beginning of this session, I highlighted something called the concept, right? I told you SP cell, which is secondary primary cell. If you look into that part, means this is the information of the secondary primary cell, which is the first cell to be added, which is, for example, 228, and this is the SSP information, and this is, for example, the SSP frequency position, and this is the band, for example, band 71, 77, 78, 41, 40, and so on, here being confirmed. And here is more information about the bandwidth part, and also this is which being highlighted that the information regarding the transport layer address and so on is being shared, which is many information related to the serving gateway and also GNB IP, and this is probably for the GNB IP address and so on. So this is the information. Next part is about the RSA confirmation message, which usually contain almost the same information. But if you look into that RSA confirmation message now, you will find that here this is the exact same target BCI which is being forwarded here. So this is would be for the target BCI. This is for actually for the 4G. 4G. This is also was included in this message, and you'll find SP cell configuration also. This is the BCI of the secondary node, or the first primary cell of the secondary cell. Secondary primary cell, which is this one, and this is the band information. And sometimes, if you have, for example, multiple carriers within this unit, you have multiple carriers. For example, you have additional S cell, which is secondary cell. Now the primary will be added. Also, this will be included within this message, which is RSA configuration message, and also was included in this one. For example, here is called S cell. Remember that, called SP cell, secondary primary cell, and this is secondary cell. So, for example, he's telling him, okay, my first carrier is 41 as a primary, my second carrier is 77 as a secondary. So you will have one carrier which is 1800 plus 41 plus 77. This is the information which is also important. Lastly, once this all being completed, now the path would be changed. If you look into that, you will find that the init B now is forwarding to the MME. It's telling him, I would like to modify the path. Instead of the serving gateway send it to me, I am giving you now the information about the secondary cell node. For example, here we'll find here this one is giving all the transport layer address, which is the IP of, for example, of this particular user GNB, telling him what is the IP of that part, and I would like to transfer the node of the serving gateway to be now transferred to the GNB. So you will find this kind of information being sent, that requesting the MME to transfer the path from serving gateway to ENODB to be serving gateway to the GNB. Once this being done, then DRAM modification will be sent from MME to serving gateway, and again, as we mentioned before, end marker to serving it will be ending the ENODB master node. Then the configuration will be done. So now we are done with the signaling. Now let's go quickly through the main issues or main troubleshooting, main problems we might face, and what kind of actions we can take. So if you look into this slide, actually this slide is just summarizing most of the common issues in the network, for example, and especially for the secondary cell failures. If you look into that part, I classified into 5 parts. The first part here is saying that, for example, sometimes the init B will not deliver at all the B1 measurement. And in this case, you might not see failures, but you will not see also any 5G services. I mean, you might receive a complaint that the user cannot having a 5G. So before that, there is one reason I didn't highlight here. For example, in the initial attach message, as mentioned by the source NRM bullets, if you zoom in here, let's zoom here, you'll find that sometimes there is an attach accept message. The parameter, this one, restrict DCNR, will be sent from the MME to the users, which indicates that this user is not authorized to use dual connectivity. So sometimes from the initial, for the attach message, not only the initial access, you will find this kind restrict DCNR. So this is also can be one of the issues that the users, for example, is not allowed to use. Also, sometimes the user himself might be disabling the 5G. So this also will be included in the attached request. The user will be highlighting, I am not supporting. So this also can be something in the attached message. Secondly, for sure, if the main switches, related switches for the ENDC or NSA is not enabled, this will be cause a problem. The B1 will never be delivered from be. And secondly, if, for example, you don't have the definition of the frequencies of the secondary cell is being added in the NLB, also this case, the NLB will not deliver the B1 event. And also this one, which I highlighted in the initial context setup request, if the user, for example, is not subscribed to 5G, so the core will tell the NLB that this particular user, he's capable of 5G, but he's restricted because he's not uh, subscribe to 5G service. In this case, well, this will not happen as well. And also, if you remember, we have this kind of quality of service. If this kind of DRB, data rate bearer, or for example, quality service 8, or this particular ERAB ID is used for emergency call, and you have high priority level. So in this case, also this, and this is real situation. This also, in this case, NLB will not ask the user because the user, this means the service is only used for emergency. So the NLB will not deliver. And the last part, which is related to the capability in general, if the user is not supporting the NR or not supporting the combination of the, for example, 1800 plus NS28, so also the B1 will not be delivered. Second cause, that after the B1 delivered, the UE himself didn't report the measurement report. So this is, by the way, the message in the here and the right here, I didn't highlight it, related to the restriction. If there is any restriction, this will be sent in the initial context of request, telling him that, okay, please don't add for this particular user because he's not subscribed to 5G. So again, going back to this part, for the measurement report, after the unit be delivered the RSA configurations B1 events, the user then send the measurement report. So in this case, for example, there is a problem, might be a problem in the SSP frequency definition. Maybe it's wrong. So that's why this kind of user, is not being able to measure. He couldn't find anything. So he'll not report this kind of measurement report. And also maybe the cell of the 5G is down, of experiencing any abnormalities, for example, down or barred or whatever. So also the user cannot measure and they will not be reported. Also, sometimes you'll find a coverage, the B1 itself is not achieved the threshold. Or you find maybe uplink interference. So the user, yes, okay, he found that it's being achieved, but he's not capable to report it because of uplink interference. This is also one more case. Assuming now these two steps being done fine, so B1. So the next step after the measurement report is being done, the next step we are expecting that the NLB, after receiving the measurement report, now it should initiate SgNB addition procedures, right? So in this case, the SgNB didn't initiate. Can be a problem in the definition itself. For example, you have a BCI conflict or missing definition. The neighbor's relation is being missed. So this will not, the NLB will not deliver a SgNB addition request. And in this case, also you can find the X2 link between the master NLB and secondary NLB and secondary, and 4G and 5G is down, for example, is not there, or is up. Also, you might find that in the neighbor definition, find the BLMN is not same. It's defined with different configuration. Those also can look into having a failure. For this, I mean, it's not consistent between both of them. There's also something like a discrepancies. Now, assume that SgNB addition is being set from the NLB to the SgNB. Now, the GNB was, this was SgNB addition request being sent from NLB to the GNB. So now the GNB sometimes might reject, saying, okay, this connection is being rejected. And this can be due to transport congestion. For example, you have congestion in the transport layer, for example, transmission faults or transmission problem, and also can be insufficient resources within the GNB itself. For example, based on the vendors, maybe you have a limitation in the number of users. So in this case, it will be rejected. And also it might be the cells was down after receiving this one, the cells was being down. So this also will be done. After passing that part, assume that now the GNB responded with this GNB addition acknowledgement. So in this case, the user, after completing this GNB addition, you need to start the RATCH process, right? And the 5G side, that he will try to send RATCH procedures from the UE to the 5G. So this is also can fail, but probably it will not be counted as a failure for SgNB. But you cannot transfer the path and you cannot start the download, and the SgNB cannot use the 5G link because of maybe several reasons, that the RATCH, maybe there is a problem in the UE himself, maybe there is a uplink interference issue, and also sometimes it's related to the RATCH configuration. So as you can see, it's being classified into three phases. Sometimes the failures will be in the LT side itself, even before sending SgNB Addition. So probably this will not be counted in the KPIs. Then it might be during the preparation phase. And lastly, after the completing the SgNB Addition and it was being successful, maybe now we cannot transfer the path because the user didn't cross this kind of patch procedures. So this is in general most of the common cases. If you faced any more issues in your network, you can just drop it in the comments as experience for all the audience. And that's it for today's session. And thank you very much. And next session will be continuing for the series of the non-standalone, which I'll try to cover all the details, even theoretical or practical, about the non-standalone. Thank you very much. And if you like the content, please share it and spread the knowledge and like it and comment and drop a comment. Thank you very much and see you next session.